Hi everyone, this is the final video for our FSCI course W24 on using R to wrangle data from APIs. This video is going to be on the rORCID package, which is a package that wraps the ORCID API and allows us to do the same kinds of things we saw in R Crossref, pull data from that API by using the functions that are built into the package. So I'm going to go ahead and share my screen. And this one is a bit different because I have already jumped into the notebook and authenticated in my session because I don't want my authentication details to be immortalized in video. But I am going to walk you through the process for doing that. So let me make my screen bigger. Okay. Now, what you need to do, I gave you the instructions in Slack, but they are also embedded in this notebook. Of course, we're first going to load our packages, very first step. And now you need to, first of all, sign up for an ORCID account. Then, second of all, go into your name in the upper right corner and click on Developer Tools. And then you need to follow the steps that I laid out here, where you must first verify your email address. Then you're going to click on the button that says register for the free ORCID public API, agree to those terms of service. And then you're going to be here. I don't want to scroll down too far because I don't want to show you my details. This is the farthest I can go right now. But you'll fill out the details, put your name, just put the ORCID website and your website URL. Put in the description field what you're going to do. In this case, we're going to get public API key and public data, and then put ORCID again in the redirect URI field. And then they have a diskette button as their save. So you're going to click on that in order to save your details. And then you're going to get a gray box that will have your client ID and client secret. And that's going to be here. You can see my client ID. So you're going to copy those, and then you're going to jump back here into this notebook, and you're going to put the client, paste, not type, your client ID here and the client secret here, and then run this code chunk. Okay. And all that is doing is saving your client ID and your client secret to this as objects to this environment. And then you're going to run this. This is from the HTTR package, which is a package in R that allows you to query APIs. So we could have actually used the HTTR package to query APIs. However, this is kind of what's in the background of API calls that the packages that we're using really simplify. So in other words, the programmers of R Crossref and R ORCID have written all of this into the functions so that we don't have to add it manually. Because sometimes figuring all this stuff out, what goes where, can take a really long time and is really confusing, and to me anyway. So it's nice that there are these R packages that do all of this work for you. But in this case, I did have to write out every little argument. And the purpose of this here is to get a API key from ORCID. So you're going to run this, and then you're going to run this code chunk, and it's going to print out what the response to this request was, which is some details about your API key with ORCID. And then you're going to run this chunk here. And what this will do is it will take the access token that we saved to this object here when we parsed the request with the content function. And that will save it into your environment. And that way it will be stored as long as you're running this binder session. All right, and then you can run this function ORCID auth, and that will authenticate with that ORCID ID. If you're ever using our ORCID in RStudio, all you have to do is run ORCID auth. So in other words, if you're not using it in the Jupyter notebook that we've used here, but rather you've downloaded RStudio and you're running it from there, if you call ORCID auth just with empty parentheses, in other words, just like this, it will take you out into a new browser window. It will have you log into your ORCID account, and then it will send the key back into your RStudio environment. But we couldn't do that here in the Jupyter notebook because it doesn't allow you to exit outside of the four walls of this notebook. So I couldn't send a message from the ORCID website into this notebook, into this binder. This binder is a kind of closed session. So that's why I had to do this kind of workaround in order to allow you to find your access key. But that access token is good. And so you can also, you don't have to run this every time. You just need to, so next time, once you get your access token, you can just save it and you can just pass it directly to ORCID token. So you can skip down to this step here and you could just paste the access token here and you can just run this function and this function alone. Okay, and then, oh, well, and this one too. So these two here, once you have your access token. In other words, the purpose of this, and this are just to get that access token. I hope that makes sense. That's really what gives you the permissions to query the ORCID API. So now I have to give my acknowledgements to ORCID, the organization, for, first of all, for the service that they provide the scholarly community, which is excellent in their attempts to help us with name disambiguation. And not just that, but also give a platform for individuals to showcase their work and to tie all of their work together. So here's my ORCID ID. And that's one of the tremendous values that ORCID provides. And what we're going to see here today is this using the ORCID API is one way of getting employment data, biographical data, publications data, depending on whether they've filled out this information, positions data, peer review data, funding data, patents, whatever work they have added into their ORCID profile and made public, you can gather using the ORCID API at no cost to you. So they do make that API, the public API, available to everyone if you followed the steps that I've just given you. And one of the principles of ORCID is that an individual controls what data is public and what data is private. So if that individual has hid any data, then the public API will not pick it up. And we see that very often with email addresses, is that many people keep their email addresses private, which means that it's not a reliable way of collecting data to just rely on email address domains. But anything that they have made public is available to obtain via the API. And we're going to see that in action here in a few moments. And one other thing I wanted to add is that if you are a member of ORCID, you can create APIs that allow you to connect to individual researchers. For instance, those researchers at your institution. You can develop an application using the API to give you permission to gather as well as edit that individual's information, as long as they give you permission. So a lot of universities have built systems to collect all of the ORCID data for their researchers and modify it and edit it and so on with that person's permission. So the other acknowledgments I have to give is to Scott Chamberlain with rOpenSci. He is the developer of this package, and he's done amazing work as always in making the package available and documenting the various functions that it can execute. Um, and I was going to say something else about that. Um, so yeah, just check out the work that our rOpenSci does and continue to support them. All right, so let's get started. I have already authenticated, and so I'm going to skip down here to finding ORCID IDs with ORCID search. So what the ORCID search function does is it takes a query and it returns a data frame that includes the IDs that match that query. It will give you the first name, the last name, and the ORCID ID. So this is what we use when we have some data about a person, like their name, for example, and we want to collect their ORCID IDs. So our example that we're going to use throughout this workbook is Josiah Stinkney Carberry, who is a fictional professor that's been around for several decades, a kind of practical joke. A professor of psychoceramics, or the study of cracked pots. But someone created an ORCID profile for Carberry, actually two ORCID profiles. And we can use that for test cases like this, and we'll do that right now. So the first thing we're going to do is we're going to assign this to Carberry, and we are going to use the ORCID search function, and we are going to use the family name argument, in other words, the last name, and we're going to pass this last name to that argument. And notice, of course, it is in quotation marks. And then we will print it out here so that we can take a look. Well, that should have already executed. So I'm going to pause the recording and I'm going to troubleshoot my access key. So I'll be right back. Okay, I'm back. I just needed to, I think I waited too long, and so my kernel got disconnected. So I just had to rerun the above functions again. And so I run this, and I can see, as I mentioned earlier, there are three columns: first name, last name, and ORCID ID. So right now we can see that there are 10 observations. By default, ORCID search returns a limit of 10. So we can increase that by using the rows argument. So here we're going to run the same exact function, but we are going to pass 50 to rows. And take a look at that. That will take a little bit longer. All right, and now we have 28, which means that there are 28 people with the family name Carberry in the ORCID data set that have made their profiles public, at least. So we don't have to look through that long list in order to find our Josiah, but we can add in another argument, and that argument would be given name, in other words, first name. So this is one of the advantages of using the rORCID package, is that we do not have to do the work of connecting these two with an AND operator, but all of this is being constructed in the back end and then passed on to the API request. So, so we give given name Josiah, family name Carberry, and run that. And we have two, as I mentioned earlier. The first time I taught this, there was only one in there. So I had to update it last year. Now we can look these up in our browser. So I can open these up in a new window and take a look at what they look like and see which one I want. There's one that's much more complete than the other. So, and I'll show you that in a moment. As we've done with every function, we can use the question mark and the function name to look at the list of fields that we can pass on to this function. So if I call that, you can see I've got given name, family name. And sorry, I just got paranoid that the Zoom switched my window and I'm not recording the right window. So I'm going to minimize this just in case. Okay, so you have given name, family name, past institution, current institution, affiliation organization, Ringgold, org ID. We're going to be going through a few of these in a moment, but this is a good way of seeing what data is in there, what it represents, and what other arguments that you can pass on to the ORCID search. And so I'll give you a chance to do an ORCID name search for yourself or for someone you know who's in ORCID. Experiment with it, try it with rows increased, decreased, and play around and see if you can find people's ORCIDs that you know. All right, one of the huge advantages to ORCID is the affiliation organization, because right now, I mentioned this in our Crossref lesson, a lot of publishers do not contribute author affiliation data. And so that affiliation data is available from, for instance, Scopus or Web of Science. A lot of that is a result of natural language processing and text mining that they do of publications in order to infer the individual's publication on the basis of, they'll crawl the first name of the publication, and they've got really sophisticated algorithms. And actually that is a tremendous value. And I give a lot of credit to those organizations for the considerable work that it took, clearly, to make that data available. But there are some issues with it. There are false positives. It's run by a computer. So it's much more reliable if the individual adds their affiliation data. And that's where we're going with ORCID, that in order to gather an individual's publications and their affiliations, better to use a source that the individual has authorized and has control over, like ORCID. And so the argument for affiliation is affiliation org. And the Carberry profile that I want has his organization set to Wesleyan. So I'm just going to put that term in there, and I'm going to run this. And here we will see the one row, which is the row that I want. So again, there's an opportunity here for you to take a look at you or your colleague to see if you have affiliation. You can also try using the current and past institution arguments if you've designated those in your ORCID profile. All right, we can search by email address, though, as I noted earlier, according to ORCID, fewer than 2% of the 3+ million email addresses are public. So this one may not be incredibly helpful. If that person has made it public, you can search for their email address directly. So I can say, this is mine, obviously. So there you go. Here's my ORCID ID, and it matched on the basis of my email address alone. You can also limit by keywords. This too, there's not really a controlled vocabulary for keywords. It's pretty open-ended. So this may not be a foolproof method to get, say, all of the physics professors or particle physics. And many people don't put in any keywords at all, but it is a method that's available to you, and so I demonstrate it here. Also, if you know the name of a work that someone has created and that they have assigned to their ORCID profile, you can use that as a way of discovering that person's profile. So in this case, Building Software, Building Community, authored by Edmund Hart and Scott Chamberlain, gives me these two rows. Really, that's really excellent, right? Like, I'm able to see the ORCID IDs on the basis of the work. But there's something very interesting here. If we look up the same article by DOI, so this is that same article, and now I am passing it to digital object IDs rather than work title, then I only get one person and not two. And the reason for that is if you go look at Scott Chamberlain and Edmund Hart's profile, ORCID profiles, you'll see that Edmund Hart added this article to his ORCID profile, whereas Scott Chamberlain added the data set to his profile and not the article. And the data set has a different DOI. So that's just something to be aware of, is these limitations. Really, the data is only as good as what people add to it, and there are limitations in what people do. So just keep that in mind. All right. On the same note of institutional identifiers, there is an attempt to create standardized research identifiers. Ringgold and Grid are two of those. Research organization, I can't remember what the R is, and I forgot to look it up before I got into this session, but there's another effort to assign institutional identifiers as a way of standardizing that and allowing us to not use names. So an example of that is I work for OSU, but it's Oklahoma State University, not Oregon State or the Ohio State University. So if we could use numeric or alphanumeric identifiers rather than institution names, it really will improve the accuracy and precision of our data. And this report by ORCID is worth reading as well. This is a kind of their assessment of the current providers of the it's I think a couple of years old, but it's a good article that reviews the various institutional identifiers. So the two of the arguments that are available in our ORCID are for Ringgold org ID and Grid org ID. One of the sort of irritating things about Ringgold is that you have to register with them in order to even just look up an institution. So you have to click on this link and sign up, and then there's limitations on it. Grid is you do not have to sign up. Grid is open for searching, and you can download the entire Grid data set. So to find the organization that you're looking for. Now, when an individual starts entering their affiliation into their ORCID profile, it will autocomplete for them, and it will populate identifier data that ORCID has on record. From what I've seen, at least when I wrote this, most organizations had a Ringgold and not a Grid. And the only reason I said unfortunately is because you do have to do that extra step of registering in order to find your Ringgold org ID. And also it's important to note that sometimes different entities on campus will have separate Ringgold IDs. So there could be like a research lab that has its own Ringgold. And not to mention the various like system schools if you're part of a university system. So you might want, if you're really going to go forward with this, you might want to take the extra step and trying to get a comprehensive list of your institution's organizational identifiers. So the challenge for you here is to go to Grid and find the Grid ID for your institution, and then run an ORCID search and set Grid org ID to that Grid. So I'll give that a shot here. Well, let's see. The challenge is not to add a name. So I'll just say OKSU gets ORCID search and Grid or underscore org ID equals, we'll look it up here. here's the ID. And you're going to make sure and put it in quotation marks. And let's search. Actually, let's search again and print it out. So it will return 10 results, because remember the limit is, or the default is 10. The limit is 200, but I'm going to show you a loop that I wrote down the page that will help you collect it all if you are going forward and you want to try and get as wide a set of profiles that match identifiers as you can. So, and then an extra challenge, if you have added your grid ID or your Ringgold ID to your ORCID profile, then try adding your family name and then one of those institutional identifiers to see if you can find yourself by passing both of those arguments. All right, we can search by name and email address domain, so you don't have to put the full email address, but you can put a star and then an @ and the rest of the email domain as well to search. All right, so that is ORCID search, which is a wrapper for another rORCID function, which is just ORCID. And ORCID allows for a more advanced range of searching, including the use of Boolean OR operators. Now, there are a number of different arguments that you can pass to ORCID. Some of those are listed here. And note, very importantly, that the difference between the arguments that we pass here, I'm going to actually call the help page here real quick. You look at the help page for ORCID search. We can see that the programmer has translated these and put underscores. Whereas if we look at the help page for just ORCID, and we move down to the what am I looking for here? Excuse me just a moment. Query. I'm trying to look for where I got this quotation. It's right here. Excuse me. You can see that they are different. So whereas with ORCID search, we used given underscore name, with this, if we're using just ORCID, we have to use it as it's written here. Okay. And you'll see an example of that in this query here. So this query, notice that it is not ORCID search, it's just ORCID. And then I pass the query. The whole entire thing is surrounded in single quotes. And the reason that I use single quotes is because I may want to use double quotes inside of the argument. And if you're using double quotes, it's safer in R to surround the entire thing in single quotes. Okay, so what this argument does is it says the family name has to be my last name, Yakavakis, and we're doing a Boolean search here. And then all of these three conditions are separated with OR operators, which means that only one of these conditions has to be true. So either my Ringgold ID has to be 7618, or my email has to be anything at oklahomastate.edu, or my affiliation organization name has to be Oklahoma State. Okay, if any one of these conditions are true, which it just so happens that all of them are true, then it's going to return this as the result. Okay, so we're going to see this in action briefly as a way of casting a wide net to catch an institution's identifiers. The other difference is the result that is returned is not first name, last name, ORCID, but rather it is the ORCID identifier URI, the path, and the host. All right. So we'll go into this here more in a second. The maximum number of returned results with an ORCID query is 200. We can modify that with the rows argument. So here you can see that I have removed family name, and I've only issued a query to get any entry where either the Ringgold identifier is 7618, or the email domain is OK State, or the affiliation name is Oklahoma State. I'm only going to return 25 results. That was pretty fast, but you can see those 25 results here. Now, if you want to retrieve a complete set, I have a feeling that some of you out there are curious and want to gather as many ORCIDs for your institution as you can. Then we have to write a small function here. So the first thing that we're going to do is we're going to try and find how many results are found with the call. So to do that, we're going to wrap our entire query in a function called attr, which comes from the base R. And then we're going to pass to attr the argument found. Okay, so this is our API call, and I'm passing found to attr, and then I'm printing that out here to the console, and that will tell me that 1,920 people have ORCID IDs that match these conditions. You can see that's changed. I modified this right before FISCI started. So just in the last, say, week and a half or so, there have been 17 people that have signed up for ORCID. It's just nice to see, affiliated in some way, either through Ringgold, email, or affiliation organization name to Oklahoma State University. All right, now this next bit might get a little complex, so I would say don't stress out too much about what it's doing. If it works for you, then use it, but I'm going to explain what it's doing. So first of all, because each iteration of the loop can only gather 200 at a time, what I'm going to do is use the seek function to construct a set of numbers starting with 0 and ending with my OSU ORCID count, which now is 1920, counting by 200 each iteration. And then I'm going to print that out so we can look at it. Okay, so we have, as we would expect, 0, 200, 400, 600, etc. And we're going to use this, and we're going to pass this into our loop. We're going to use map. And what I did here was I commented this out so that it would cause an error if someone ran it, because I didn't want someone just running this if they weren't really interested in running it. So you have to take the extra step here and delete the comment so that it will actually run. And what this does is it runs map, which you might remember from our Crossref. It's an efficient way of running loops. And what it's doing is it's mapping over and it's taking my pages up here, 0, 200, 400, 600, as the argument to map. Then I'm going to write a custom function that takes the argument page. And what this custom function does is the first thing it will do is print the page out. This doesn't work in Jupyter Notebooks because it doesn't report back while the entire chunk is running. It does not print any output until the whole chunk is done. But if you were running this in RStudio, every time the loop iterated, it would print out 200, 0, 200, 400, 600, and that would help you kind of keep tabs on where the loop was and make sure that it was running properly. Okay, so the first step is to print out the page you're on, and the second step is to assign to the value my ORCIDs and run an ORCID query for Ringgold ID. Probably should have added grid org ID in there as well. email address, or affiliation name. So remember, these are all separated by ORs. So as long as one of the conditions is true, the ORCID ID will be returned. I want to get 200, the maximum amount each time. And I want to start with page, whatever page it's on. So again, the first page is going to be 0, the second page is going to be 200, the third page is going to be 400, etc. And then I'm going to return that to the loop. So I'm not going to run this just because I don't want to waste the processing data, but this is an efficient way of gathering all of the ORCID IDs that you possibly can that belong to your institution. So actually, here's what I'll do. I'm just going to run it through pages 1 through 2, and that'll give us 400. Shouldn't be too much. All right, so I've done that. Actually, that was incredibly fast. Let's see if it worked. So the next step that I do here is a little bit of cleanup. I retrieve the ORCID IDs. Let me print out to you what it looks like. So it's a list actually. This is the first object, the first set of 200, which is a data frame. And then here you can see this 2, that's the second set. So that's why you have to use bind rows to kind of squish it all together into a single data frame. And then I always use this clean names here throughout this entire workbook, because these identifiers come to you with all kinds of these column names come to you with all kinds of punctuation and kind of messiness. So the clean names function, which comes from the janitor package, helps to clean and standardize those names. So I'll go ahead and run this. Okay. Yeah, I had a feeling this was going to happen because bind rows actually changed since the last time that I ran this function. And when I tested it, I didn't test it out on this data. I think that I fixed it down below. Let me see here. I'm going to pause the recording real quick. Okay, yeah, I fixed it in another function that I use this, but not in this one. So I'm gonna have to go back and fix this Jupyter notebook for you so that it is correct. But for here in the video, what I had to change it because the function changed, which that happens with our packages. They change and evolve over time. And that's actually one of the caveats of reproducible research, is to make sure that you're always specifying the version of the package that you're using at the time. Because if you update all of your packages and some of the underlying language for the function changes, then the function breaks, like we just now saw. So I mean, that's a good lesson for us all to keep in mind, is that always document the version of packages to make it, when someone is attempting to reproduce your work, to make that clear. So this was the workaround that I figured out below, which I will replace as soon as I have some time. And what this will do is it will take that, what we saw here was 2 lists of 200 row data frames apiece, right? And what this does is it runs map DFR, which outputs a data frame where binding by row, and it coerces it to a tibble. Don't worry about what all of that means. Just know that it works. And now we have a data frame or a tibble of 400 rows by 3 columns. Then I also run the clean names function in order to, and you'll see the slight difference. It replaced the slashes and periods with underscores, and it made everything lowercase. Okay, so if I was to do that for this entire page, instead of, if I was to remove this braces and run the entire thing, then I would have 1,903 records. We talked about the pipe operator, I think, last time. Again, just remember that all it's doing is it's taking this as the output and it is feeding it to this next function as the input. So I'm taking my list, then I'm basically flattening my list, then I'm cleaning the names. All right, and you have a chance to try this for your own institution. Once you're prepared and you have your organization's Ringgold, grid ID, email, and affiliation name, you can try it yourself, reproducing the same things that I did above. And then at the end there, just make sure you're using this and not what I had written there in place. Okay, I did also talk about this in the previous session, but I'll go over it again. If I wanted to save this data, now that I've flattened it, I can't. So let me call this my ORCID's data here. Okay, so I've run that same operation and I've just renamed it to my ORCID's data. Now, if I wanted to write a CSV for that, I could execute this function here. Then, as long as I'm still in this binder session, if I go to File, Open, and I go into the data folder, there I have my ORCID's data, and I can download that file. Now, again, remember that binder sessions are temporary. So as soon as you close out of your binder, this file will disappear and it will just be the files that I loaded into this binder notebook. Okay. But that's how you can save your data from here. All right, so far, all we've been doing is getting ORCID IDs, but we haven't actually been getting any data from the ORCID profiles. So there are a set of functions that allow you to do that. One is called ORCID person, and what this does is it will give you that person's biographical information. So unlike ORCID or ORCID search, this does not take a query. So we have to already know our ORCID IDs, and we have to pass those ORCID IDs to ORCID person. So in this case, I already know Josiah's ORCID ID, so I'm just going to assign that to this value here, Carberry ORCID, and then I'm going to pass that to ORCID person. And let's take a look. All right, now this comes back as JSON, which we talked about in our crossref. I'm going to jump over to the lesson in the website to show you what that will look like. All right, so this is Josiah's, what comes back. We can see that it is very complex. Under last modified date, we have the date that it was last modified. Under name, we have a list, and in that list we have the date that it was created, the given names, and there can be more than one value in some of these. The credit name if the person has filled it out. Other names, so there can also be multiple other names. And here you see this super confusing when we expand other name. Like we get the content, which is the good stuff, the alternative names for Josiah Carberry, but then we have stuff like path, last modified for each one of those, the URL back to the original. So this is where things start to get a little bit messy, as we're going to see. Actually, it's not messy. It's very clean and structured, but can be difficult to deal with if your end goal is to flatten this complex nested list into a two-dimensional CSV. We have his biography, which again also has its own created and last modified date. We have his researcher URLs, which are any external URLs that the person has affiliated with their account. So in this case, the person who created this profile has put a link to Josiah's webpage on Brown University and a link to the Wikipedia entry on Josiah. And those links are all the way at the bottom under URL value. Okay. Email addresses, he has none on file. Addresses, he has none on file. Keywords, he has 2 on file, and we can see those again under content. And then external identifiers such as Scopus or Scopus author ID, or which is what he has here. And I think that's the only one it is. So it has the Scopus author ID, the value, and so on. So a lot of information, a lot of really good information, but it's nested fairly deeply. So the next thing I'm going to do is show you some tricks to get that data out. We can see the names of all of the top level elements that we just looked at by calling names, and we put in double brackets the number 1, and what that is reflecting is this. It's the first item in the list. And then, okay, so here's the trick that I came up with to get the data out. And basically what I do here is build up a flat data frame column by column. This is the most precise. Absolutely, it's a bit time consuming, but it allows you to be very specific as to where you are grabbing the data from. So I call my Carberry person list object, JSON object. Then I pipe in, and then I need to include a brace here. I'm not sure why. That's just the way that this works. And then I call the function tibble. I may have mentioned this briefly in the data exploration video, but a tibble is just the tidy versus efficient data frame. So base R had what they call a data frame, which is just a grid of rows and columns like you would see in an Excel spreadsheet. And a tibble is an improvement on that implementation. So I'm creating a tibble, which is going to be rows and columns. And then the first column I'm going to call created date, and that will use the per function to, the map double function from the per library. And map double is numeric, and that will use the period indicates whatever I have input into this tibble. So the input is this JSON object. So from there, I want to pluck, you might remember that from our previous 2 lessons on lists and our crossref. I'm going to then index into name, created date, and value. So I'm going to index into name, created date, and value, and I'm going to grab this object here. And I'll talk about what that number is in just a second. Then I'm going to set the default to NA, and what that means is if that's empty, then it's going to return an NA. And and that is helpful because if the list object is empty and you don't pass in an NA, then it's going to be what's called a null in R, and that will be completely empty, and that will throw some wrenches in your analysis down the line. Okay, then I create another column called given name, and that indexes into name, given names, value. Again, name, given names, value, Josiah, and so on. Family name, credit name, other names. Some of these are map character. I misspoke earlier when I said given name and family name could have more than one value. They cannot. They can only have one. But other names can have multiple values. And so here, with these, I'm able to pull it out because I know that if it's there, it's going to be a character. But with these, if it's there, it might be a list, like, okay, which it is in this case, is other names. If I index into that other names, other name, content, then I have 3 items there. And you can see other names, other name, content. So just calling map will pull those 3 names in as a list that I can then later on down the line, I can unnest that list if I need to. All right, the ORCID identifier path, I definitely want that. Biographical information, any researcher URLs, you'll notice this one is also a map, not a map character, because there can be multiple URLs. Emails, there can also be multiple emails, there can be multiple keywords, and there can be multiple external IDs. So all of that is a long way of saying that is one strategy of getting all of this into one place, a good, nice data frame of biographical information from a highly complex nested JSON list. All right, moving on. You notice that date was this number here. Last modified date was this number. This list viewer parses that out because it recognizes it. What that number is what is called Unix time. The number of seconds, or in this case, the number of milliseconds that have elapsed since January 1st, 1970. So there's another library that's called Anytime. And what Anytime can do is it can easily convert times and dates. So what I do here is I'm going to create just a new object here. Call the Carberry data, which I created here, this data frame. And I will use mutate. And what mutate does is it allows me to change the data in this data frame. So I'm using mutate. Now, if I had put a brand new column name here, then it would create a new column with that name. But here I'm just going to reuse the name that we already have in there, created date, which you can see that's what I called this. And so what that's going to do is it's going to overwrite the data that I had there. So I'm going to overwrite created date, and I'm going to use the anytime function from the anytime package. And that function will take the created date from each row. In this case, we only have one row, and it will divide it by 1,000. And that will give us a nice, neatly parsed date and time that we can understand. So this profile was created April 15th, 2016 at 10 o'clock p.m. UTC. Not Central. Yeah, Central Daylight Time. Is it? I think it's UTC. So that's a misstatement there. But that's how you can convert that time. All right. Now, there's other functions in anytime. You can use any date, and that will leave out the time, and it will just give you the date. And then, I don't want to overwhelm y'all or make things too complex, but you can also use the year function, and that will parse out from the date. Here we created an entirely new variable, created date. Oh, I'm sorry, no, we didn't. We just overwrote the previous one. So then this then goes to that and extracts the year. So if you want to just get the year out, you first have to use one of these two functions, any time or any date. You cannot use year on the Unix time. It won't understand it. All right, moving on to unnesting nested lists. We talked about this in the R crossref. What this does is, so we know that keywords has two values, psychoceramics and Ionian philology. So I don't want to get too deep into weeds here. Some of this is kind of more for those of you advanced users who want to take this the step further and read on your own. But what this does, this map LGL, is what will tell us which all columns are potentially nested lists that have more than one value. And then if we use the unnest function on that, it will basically create a new row for each one of the values in the nested list. So in other words, in this case, we unnested keywords. So it's going to give us two rows now instead of one. And if we scroll all the way to the right, we will see the keywords. And now, instead of the keywords being bunched together in one cell, they're each separated out. And this would be helpful if we had a big list and we had a bunch of people who studied a bunch of different topics and we only wanted the keywords to be in their own cells. So read more about this if you would like. Okay, now we get to writing CSV. It's really difficult to write this to a two-dimensional object, as I've been discussing. So I give you a few different options here, and I discuss these at much greater length on the website here. So I would encourage you to read this to get your options for how to write this to a CSV file. One of the easiest options is just to drop the nested lists altogether. Another way is to unnest each one of the nested lists, although that's going to give you a huge amount of rows because it's going to recreate each row for each unique value. So you do have some choices to make if you're going to write it to a CSV when it comes to dealing with those nested lists. And if you, once you kind of get started using this, if you want to reach out to me with any questions, I'm happy to help with that because I've banged my head against the wall plenty trying to figure out solutions to this issue. So now you have a chance to try it yourself if you want to get your ORCID biographical data and run this function to see if you can transform it into a data frame. You can also pass multiple ORCIDs on to ORCID person and get their data. So that would look like this, right? Instead of just one, you have two. And I talk about that more on the website, and I give you a chance to try it yourself if you want to try that. I'm going to skip this portion on searching by names. Basically, I go through a long exercise in taking first and last names and writing a function that you can pass then to the ORCID query to get to the ORCID function to search multiple people by name. This is helpful if, say, a department gives you a list of their names and says, find everyone in ORCID who has an ORCID identifier, and all you have is names. Well, then you want to be able to automate that, and that's what this set of code chunks does, is it helps to automate that. And then this I just put in as a little bonus. If they give you the names like this, but you need to split it into first name, comma, you need to split it into having the first name in one column and the last name in another column, then you can use this little neat function to do that. Okay, we're nearing the end here. A couple other things I want to show you is ORCID employment data. I'll show you what that looks like here. This also comes in a series of nested lists. So here I basically just use pluck to get the data out that I need, and then use flatten to flatten that into a data frame. I hope this still works. Yeah, it does. And then I mutate at the end, and I take all of the dates and I just run the anytime function on those dates to convert those into dates that we can understand. So in this case, I've just passed my own ORCID ID to ORCID employments. But since I have 3 employments on my ORCID profile, then it's showing all 3 of those. When I worked at UT Arlington, at University of Houston Clear Lake, and now at OSU. So this is a way of getting an individual's employment data, and you can get employment data for multiple people. Excuse me. And then I go through an exercise here where to try and get whether or not they are currently employed there, I look to see if the end date is NA. In other words, if they have not entered an end date, with the assumption that is hopefully correct in most cases, that if they've not entered an end date, they are still employed there. And so this is a way that you can gather currently employed people at your institution. This will take some practice and reading, and it's probably a little bit too much for me to go into in detail in this video. The last thing that I want to go into is how to get the works, in other words, the publications or research that a person has put into their ORCID profile. And the way you do that is with the works function. Works, just like employments and person, only takes an ORCID ID as its argument. So here too, I am going to pass the ORCID ID to the function. I'm going to flatten it, which I think this was one of the ones that I corrected, I hope. Yeah. Flatten it out into a data frame, and then clean the name. So this one is not as complex of a nested JSON list as some of the other ones we've been working with. So here, these are Carberry's research works, and you can see, as you would expect, the type, the when it was actually added in, when it was created, and where's some of the bibliographic metadata? Here we go. The title, any external identifiers like ISSN or DOIs, and then any other values. So a lot of publications data in ORCID, especially if it's manually entered, is really shaky. But ORCID has created a lot of tools now that allow you to import work directly from a Scopus profile, or from Lens, which has some patent data in it, or from Web of Science, or from Archive. There's many, and from Crossref as well. So I think that as more researchers learn those tools and make use of them, then the completion of the publication's metadata won't be as much of an issue. So again, here, this goes through an exercise of unnesting the external IDs, which would allow you to then extract the DOIs. And then you could take those DOIs and you could look them up on Crossref if you wanted to get a complete set of bibliographic metadata. Then, if you had the permissions to modify someone's profile, you could use that to add detail into their publications. And you can also get works on multiple people. So you can pass a vector into ORCID Works and get all of the works for each of those persons. So that brings us to an end on our ORCID. I hope that wasn't too much. I would, again, encourage you to reach out to me personally if you have any questions. And as you're working through this during the course of the class, you can put any questions you have into Slack, although we only have a couple of days left. So, and then I'm going to create one last video that is just going to discuss what's next. If you want to install the ability to run Jupyter notebooks on your own computer instead of here in a binder, or if you want to install RStudio and R and run that from your own computer. And so I will talk to you then.